So we're going to go on and have a brief look at accuracy of measurement. If you were on the foundation course, you will have already seen a lot of this already. We're talking really about why we need to be accurate in our measurements, why we need to be clear about what we are seeing. So the first thing you're going to come across is thinking about rounding of numbers. First of all, how could we express the distance between the university, Brighton University, and Buckingham Palace? Just as a thought. Number of ways we could express that. We could say it's this many centimetres, 10,605,580 centimetres. Does that make sense? Probably makes more sense actually to call it 106 kilometres. That enables us to make a bit more sense of the numbers. And it's the same with medicines, etc. Sometimes you come up, when you do complicated calculations, you often come up with very large numbers with lots of numbers after the decimal point, and you don't actually need to have all of those to get a sense of what you're looking at. Okay, this is a link to Jonathan Edwards' world record triple jump. I would recommend you look at it if you get a chance. I'll put the link on Student Central. Do have a look. It's lovely to watch. I would say that because I like athletics, but it's a fantastic thing to watch. So you can pause now if you want and go to Student Central, have a look, and then come back. Welcome back. So from that triple jump, you'll have noticed the following figures. So the previous world record was 17 meters 98. Jonathan Edwards' new world record was an astonishing 18 meters 16, and then 18 meters and 29. Now, normally, when you have world records happening in athletics events, you might get a couple of centimeters more each time. And you can see these are significantly further. So he's well over 30 centimeters more than the previous world record, which is fantastic. But imagine if we rounded these up. So if we rounded those up, what we would get would be, the first one would be, let's say we rounded them up to two significant figures. We get 18 meters on the first one, on the old world record. Then the first time he broke it, the 18 meters 16, that would be rounded up to 18 meters. And then the 18.29 would have been rounded up to, well, 18 meters. So we need to choose when we do our rounding up. And you need to, it really comes from having a sense of what you're trying to do with the numbers. So that's the important thing really here. One of the things you do have to think about is that you've always got to be alert when you are doing these calculations. Just make sure you're in the right, you're looking at the right things. So in terms of pharmacy, we'll often have situations where we want to round up, and this sometimes gets people confused. But if the final digit in the number is between 1 and 4, we round the next last number down. If it's 5 or above, we round up. So 1, 2, 3, 4. If we wanted to go to 3 significant figures, would be 1, 2, 3, 0. Whereas 2, 3, 4, 5 would become 2, 3, 5, 0 because we're rounding up that last number. That's important in calculations, and it's always good to remember that try not to round up until you get very close to the answer. If you do too much rounding up or rounding down as you're doing a complicated calculation, sometimes you can get you can vary the figure quite significantly. Finally, thinking about accuracy and what we call assays, this is where we need to know how much is in a tablet. So for example, if you have a paracetamol tablet, it says it's 500 milligrams. Now, once you've started to do some work on how tablets are produced, how medicines are produced, you'll realize that actually a lot of it is done in large scale. So we don't have somebody measuring out individually 500 milligrams into each tablet of paracetamol. What happens is you make a large batch, and the assumption is that batch is well enough mixed that for every amount which comes out for a tablet, that will contain 500 milligrams of paracetamol. And whether it does or not is a good indicator of how good the process is. So what will happen is that where you have standards, pharmacopoeia standards, then they will actually say what the range is acceptable. Because as I say, it's rarely 100%, and the sorts of range you might get, say, 95 to 105%. So the European Pharmacopoeia states that the range of active ingredient for aspirin 300 milligrams is actually 95 to 105%. So it's 5% either way. And if you work that out, that comes to, so any one aspirin tablet should contain somewhere between 285 milligrams or 315 milligrams of aspirin. So this is all to do with standards and accuracy of the medications we're taking. So that's just been a quick run through of some of the fundamental stuff around numbers and rounding up, etc., and accuracy. So good luck with that, and I hope that made some sort of sense.